Hello, and welcome back to the Automation Insider. I'm your host and systems design lead, Joe McGrath. I work at Hy-Tek Intralogistics, and I love designing big systems. But sometimes when you have a system that's complicated or has a lot of products flowing through it or moves really fast, you have to figure out what all the stuff is really fast. And what we use a lot of times are barcode scanners and vision technologies. And this is a topic that comes up on project after project after project. And so I thought, why don't I call one of my old friends that I've worked with for, I don't know, maybe 10 years, Scott, and have him educate me or re-educate me on the topic. So Scott, go ahead and introduce yourself.
Hi, I'm Scott Ichikawa. I've been in the material handling world for about 15, 16 years now. Cut my teeth back in semiconductor robotics. Since then, I've been a systems design salesperson. And for the last 9 or 10 years, I've been in the vision and barcode reading sensor space, helping integrators like Hy-Tek put together systems and create decision points to help them route packages throughout their warehouses.
Very cool. Very cool. Well, it's good to get to work with you one more time, Scott. I'm pretty excited about it. We always have a good time. You always teach me something that I didn't know before about sensing technologies. I feel like a lot of times I'm just guessing, and then I call an adult and they help me figure out what you actually do. And very often we can do more than I think we should be able to do with the technology. So let's talk about a couple of like the maybe bigger technologies that are out there that people use a lot, but maybe we don't necessarily talk about a lot in the industry. So stuff like maybe optical character recognition or something like that. And we hit barcodes all the time. I think everybody feels pretty good about barcodes, but like, what if it's not a barcode?
Well, I think that's one of the interesting things that the industry is exploring right now is how can they step beyond just a barcode reader and what other information is on the label as well as the packages that they can connect to that maybe isn't in their database that they want access to make informed decisions through their business processes. So optical character reading is one of those areas. Right now, the biggest use cases that you guys might be familiar with is like license plate readers or processing documents, like scanning a PO with your phone and having all of that automatically entered to improve throughput of data entry and accuracy.
Yeah, receipt apps.
Exactly.
I love a good receipt.
I hate the receipt apps because then, I don't have any control of what goes in, but hey, that's a different story. So optical character reading in the warehouse is kind of exploring a new phase because technology has gotten better and faster, especially on the compute side. So you can actually pull information off of the box and make decisions from them. And the biggest kind of, we'll call it concern point in the past was it would take 10, 15, 20 seconds for you to get that data, transfer it back to a warehouse management system and then make a decision. But all that's condensed to the point where you can probably do it in the 5 to 6 second range, which makes a decision point now viable.
Yeah. So I got a case of blueberry juice, and there's no barcode on the outside of it. This is a thing that happens fairly often, but it does say blueberry juice, and it says like SKU 1522. Like how would I go about using like an OCR device? Like what might those look like? What kind of workflow?
Yeah. I mean, it's just like any other standpoint. You would run it right by a camera. Depending on the number of sides you have to do, it can increase the complexity of the situation. But boiling down to like a simpler description for this purpose is you would take an image of one side and you would look for an identifier like SKU or SKU number or part of the package that you're used to seeing the label in and lifting it off and sending that data back to the system to be interpreted. Other use cases beyond your blueberry juice example that have been really popular are taking PO or SKU numbers off of the side of boxes.
Okay. Yep.
That you don't know what's necessarily in them because you're receiving them from overseas and they don't have a very good or they don't have any barcode on them. So it's otherwise unreadable and it has to be manually processed. Huge bottleneck in a lot of places.
It's a super common receiving problem, actually. I think I've bumped into this a ton of times. So yeah, we got to give it to Jesse. Jesse enters the PO and then we receive it. And it's like some weird RF station that you'll find on
the and then they'll print a label and slap it on and now they can induct it into the system.
Yeah.
I mean, taking that person out and that labor out is a huge bottleneck relief for the rest of the system because then they can just toss boxes onto their induct line and have it run.
Yeah.
And that was one of the challenges is like your blueberry juice example is probably something you could do with a single side or even a classification style, which we can talk about a little bit later, where you can look at it and identify it as that SKU without any indicators other than like a graphic or image. But the challenge for the the other example we had used is that for 5-sided, it's very difficult to deal with perspective. And then that perspective has to be like normalized on the compute side. And then you also have to then figure out what you're looking for on the box. It's a big challenge. But as I kind of mentioned, the better compute, you can call it edge learning AI or whatever you like, but those tools have made it a lot more viable for those processes to now be in solutions.
Yeah. I mean, like 20 years ago, OCR was like a thing that you would do on a PDF scanner, and maybe it would work 80% of the time, but now it's okay. So can I still, let's say that there's like a bunch of numbers on the outside of a box. And so with a barcode, if I hit 15 barcodes, I'm going to have some kind of hierarchy logic that says like, this is the nomenclature you want to look for first. If you see this, take this part out and pass it on. Can I do the same thing with OCR stuff? Is it more complicated? Is there something we got to watch out for?
No, you can do a lot of the same things. I mean, the biggest thing is if you have a backend database that you're expecting. So for example, you know that your potential text that you're looking for is one of 50 or 100 or 1,000 examples. Mm-hmm. Those are all loaded somewhere that you can just check against a lookup table. Then you have like a verification process that actually makes it very, very accurate, right? Versus purely unstructured where you're just grabbing everything off. Then you kind of get into that PDF 80% world, maybe not 80%.
What do you think it says?
Yeah. We're like 99% sure it's this, but about 1 or 5% where you're not correct can be a problem. But yeah, with some type of back check, you can definitely do any type of hierarchies, or you can train it to ignore certain things or pull substrings out. There's lots of options on how you can tackle that.
Okay. So is this so the OCR is much better now than it used to be. And I think it used to be just like maybe some algorithms that like would try to sort through like what a letter looks like. Is this largely an AI application today? Is that what has kind of unlocked it, or?
I don't know if I would use the word AI off the bat, but definitely taking some edge learning and teaching algorithms and pre-trained models that you're then adjusting. Because a lot of it used to be a little bit more rules-based vision where your character had to be, X millimeters tall and look like Y, right? And you would
New York Times sans serif.
Exactly. You would train the font, you would train the size, you would train a lot of different things of what to expect. Now you have a lot more flexibility because, to your point, I guess there's a big difference in my mind between edge learning and full AI, but you basically use trained models to then do a lot of that lifting for you.
Okay, very cool, very cool. What's like the edge? Like, what's the like kind of limit of like an OCR use case? Like, when would I start saying, man, this is not the fit?
So I would say fully unstructured where you have no backend check is very challenging, right?
Okay.
You can do a lot with perspective. You can do a lot with different prefixes. As long as you've got some type of hook where you can have your algorithm looking for something, that's where I'd say it's very viable. Once you lose that, then it becomes a little bit more of a challenge, and not necessarily because the system can't find it, but it will take longer to find it. And the accuracy, then I would put in a little question mark beside or an asterisk, right?
Okay. No, very cool. Very cool. All right. So you mentioned categorization a minute ago, and you said you're going to talk more about that. And I've heard this a couple of times, and give me a definition to make sure I understand this the right way, and then let's dive into it.
So categorization can mean a lot of different things, but really you're just sorting, except by a picture instead of a barcode. So one of the most common use cases might be like pre-sorting your polybags out to a separate line, because as you know, as a material handling designer, polybags really screw up your ability to do certain things with dots, right?
You should be careful. Yeah.
Yeah, exactly. Always a red flag. Things like sorting by tote color, you can classify by color. Or you can get into a little bit more complex things like by classifying by like a type of bottle or something like that, right? Yeah. These again are edge learning applications where the model is like mostly trained, and then you add examples for them to then lock into. And then as you run through it, through product, it's a little bit of an iterative process where you can correct the algorithm where it's wrong and come out with a pretty well-trained sorting algorithm for these types of, or sorting program for it.
Okay, so I got like a stream of products, let's say, right? And I could have an imager look at it, runs it through the algorithm and says, hey, this one's a bag, and this one is a pack of bottles, and then this one's a corrugate box. And I could have the material handling equipment respond accordingly.
Correct.
So that
you don't have to have a barcode. You can just sort it. So like you don't have to have a database saying this barcode is associated with this package SKU. You can do it on the fly on device. And you can even do it, offline from any database because of that. So it's really powerful in that regard for like pre-sorting stuff.
Yeah, and like, a lot of times if your presentation, I worked with an engineer a long time ago. His presentation's everything. So like, if you flip a poly bag over and you only had two sides, like now you got zero sides to read.
Yep.
Because one's down, and it would be a big problem. But if I knew it's a poly bag, I can deal with it accordingly. And when it was wrong, deal with it accordingly.
And then situations where like you might have like the mailer jiffies that kind of look in between a box and a poly. The algorithms typically have an opportunity for you to correct that on their UI to say you want to treat it like X or treat it like Y, and then can learn from that and then associate those with polybags or boxes as you want down.
So I like, if I understand this correctly, like it's going to look at the thing and compare it to like a database of other images, right? That's what you've trained it on. And it says, I think it's like this set of images. That's cool. And historically, when I've done like imaging applications, the main thing, aside from the cost, it used to be very, very expensive. I think that's changed a lot recently. But the second thing was, man, I don't want to like mess with this database. How much training do you have to do? When do you have to retrain? And then how long do I have to run a system before I'm like, man, this thing is dialed in? Like what's kind of the operational feel of that?
So it really depends on your SKU variety. So one thing that I found in implementing some of these systems over the years, if it's pretty distinct, like for example, carton versus polybag, not hard. You train 10 images, you're done. Right? To your point, previously you might have had to train hundreds of images to get these types of things done correctly. But now, because the algorithms are mostly pre-trained, you have a lot faster of a go-live process. Now, you get into situations where you're trying to do like item detect, which is still a classification, right? It's yes or no, it's empty on a unit sorter. Mm-hmm. But you've got, clothing SKUs that number in the hundreds. Now your image database has to be a little bit more robust, but still, it's going to be way faster and way more viable than it would have had to be in the past. And the best part is, instead of like having to update your database constantly with every SKU, you just keep an eye out for errors. And when errors happen, you would add that one to your model and it would then go back to run. You don't have to create a separate database. It's all on device for the most part. I mean, there's off-device computing options as well, but I really like the on-device ones because it's a lot easier to implement.
Yeah, there's always this like lag conversation when I have a database or like some machines and like maybe it's in the maybe it's on the cloud and someone's got to go like calculate how many milliseconds I got to wait. Every millisecond is like a length of conveyor. This is the very frustrating part about that.
Yeah,
and you have to pull air somewhere, and it costs money.
And what's nice though is like compared to the barcode scanner, which can do something in like 20 to 50 milliseconds for a simple application. Mm-hmm. Some of these vision applications are now you're in the 250 millisecond range, which under a quarter second, right? So you're now actually in the viable point. To my comment earlier about OCR too, is like these things that used to take so long that it was not viable are now entering the point of viability for decision points.
Yeah, but quarter second is, I don't know, a zone or two of conveyor. 30 seconds is we gotta talk about a buffer layer. Yeah. This is problematic, and then everybody like runs away from it.
Not to mention the imager itself has to buffer 30 feet or 30 or 60 feet worth of images too, and then that's a whole different problem of how do you pre-process those or process those so they're efficient.
Yeah, absolutely. Okay. So I've done some testing with it, and like there's definitely like limits to the technology and like when it makes the most sense to like, hey, can I use a vision for categorization? I've done like two very similar bottles, and like that seems hard. So I think contrast is a big item to keep in mind. What other attributes would I want to consider?
So shape, contrast, color, things like that can make it a lot easier to differentiate. But I mean, really, if you can tell at a very quick glance as a human, I think you've got a shot these days, right? Like, are you going to be able to tell the difference between 10 different vintages of the same wine bottle? That's going to be pretty rough, right? Yeah. But the only thing different is like the year marker in the corner of the label that you can barely see, or that you don't even know is there. But, like Diet Coke versus Coke, that's an easy one to think about. Or like, you get into the point of differentiating between your blueberry juice example earlier, different types of juice or different fruit juices. That should be pretty easy. So like these are entering the stage of viability for those types of applications for sure.
Yeah. But the bigger the difference in the things, the better.
Yeah. I mean, to the item detection thing I was talking about earlier, we did it for a clothing company, and they had like 20 variations of pants that all, but the only difference was like the size or color. So you didn't have to train different sizes because we were just doing yes or no. But if you started trying to do differentiation between those different SKUs, like this is SKU X, this is SKU Y, that would be really hard to do because you can't tell from an image looking at something that it's size 5, 6, 7, or 8, right?
Yeah.
You have to see a label for that type of information.
And then you try it on, right?
Yeah. So once you start getting into the point of that, or maybe the thousands of SKUs, or higher than that, those become a little bit more questionable. But you should always talk to your vision provider and see if there's a test or something they can do on their lab or whatnot, and they can usually prove it out pretty fast whether it's a yes or no.
Yeah. Interesting. Like I've a long time ago, I've done some like big like loop sorter projects, and they had like occupancy sensors, and I don't know that they were vision. Like, what's the advantage of like those kind of classic occupancy tunnels versus using a piece of vision?
So there's we'll call them legacy, but there's two different types of sensors out there that are on most unit sorters. One is like an array of photo eyes with a reflective sorter, and those are the nice thing about those is they're really simple, right? They're just looking at a reflective strip on the unit sorter. They reflect back. If it's covered, you'll see a dip in the photo eye signal, and it's a yes or no, right? The downside to those is they have no ability to deal with like dirt or like a flapping label that got caught on it, or maybe a piece of cardboard, like debris basically would really destroy their ability to do their job. Not to mention, you don't get there's a recurring cost of having to replace the reflective strip from wear over time and having to track which ones need replacing. So if you're not diligent about it, then your unit sorter of 1,000 trays might only be running 900 trays because 100 of them are in a state of constant full.
That's 100. Somebody had a boot print on one of them.
Yep.
And it was like, oh, I tripped it out every time because I thought, oh, this boot print. It was like the maintenance guy should not have been stepping on the sorter for one. But we basically lost the tray for 2 months because we couldn't figure out that it was a boot print on one of them.
Yep. And then you get the other one, which is a pure 2D sensor. So it's a little bit more of a rules-based sensor, kind of like I was talking about. So again, it's going to have trouble dealing with like a label sitting on the tray because it's going to see that label and say, yeah, there's a package there because I see a shipping label.
Mm-hmm.
It's a little bit more robust against things like, debris or things, because you can train it to ignore something beyond a certain size, but you're never going to want to ignore a 4x6 label because, that's pretty often you're going to want to sort that.
It seems like it's part of a package.
Yeah. But on a edge learning model or an AI model, we can call it, you can actually show those examples and treat them as empty, and the store should be able to adjust and then ignore those, and so that you can kind of space out your routine maintenance a little bit more to the point where you get these. Or you could make a third classification of dirty tray, tag it, and then when maintenance goes through, they can say, hey, which one of my trays have a dirty tag? So I can now sit there at the maintenance bay, cycle through the 15 to 20 trays I need to clean, and your problem solved, rather than you have to be going through sensor data and like photo eye data trying to figure out which ones are broken.
I think what they do is they just cycle it one tray at a time and look at it.
Yeah. But 1,000 trays, start and stop on that thing it takes a few minutes, if not longer. So you could be there all day.
Yeah.
If you know which 15 trays you have to fix.
Yeah. Or they just you let them run. And like, it's a loop sorter. This is, on a linear sorter, like a shoe sorter, like it just goes straight and you don't necessarily lose capacity. Like you're nibbling away at like this huge investment you had. So you lose 100 trays on 1,000 tray sorter. Like that's 10% productivity just because the sensor can't figure out what's going on. It's not even a mechanical problem.
Yeah, and if you don't have the error programming in there to recognize that, you may not even know.
It's like you're explaining what happened to me 8 years ago. So it's beautiful, right? Okay. So we hit OCR, we hit categorization, we hit item detection. The other big application that I run into all the time, and I've handled this, like, I don't know how many different ways, and I don't know really what the best one was. I think it's application specific, but I want to know how big stuff is because that is important for all kinds of reasons. Some things I need to know to tell like UPS how big it is because there's a financial impact to that. Sometimes I need to know how big it is because I have a robot that's about to put that onto a load or manipulate it somehow. Sometimes I want to make sure that I'm just not putting a box that's too big for my machine through the machine because then the box and the machine don't work after that. So it's no damage prevention. Tell me about like, and I think historically, and you probably have way more experience with this than I do, but a lot of times we'll use the low rent version is let's have a couple of photo eyes. If it's over the big photo eye, then it's big. You'll still see that as some protection stuff today, but that's less common. Then there's arrays where you figure out which photo eye you hit. And then there's like the diffuse lasers where you can kind of figure out distance, but none of those are like terribly accurate.
Yeah. So there's a couple ways you can do dimensioning in motion, right? I mean, and the more historical one on the higher end is the time of flight laser systems, right? Those are great. Don't get me wrong; they've been around forever, and they produce great results. Vision-based dimensioning is a little newer. Usually use like structured light or some other type of lighting arrangement to give feedback to a 2D or 3D or a combo of those sensors. Nice part about it, it's good. It gives less reflectivity than some of the laser-based systems, right? So you can deal with shiny packages or water bottles. That's always the biggest pain in the butt for dimension.
Water bottles cause me an incredible amount of heartache. Wouldn't think.
Oh, yep. And then the other nice thing is like if you have multiple use cases in your warehouse where you might have static and in motion dimensioning, Vision can do both, so you can kind of standardize on a model, and you can make sure your maintenance team is trained for one, rather than a lot. The common static one I'm thinking of is that you have to induct product into your system, and you're sitting there with like a measuring tape and trying to measure it out or something like that.
You're the scan guy, right? They have that one station, and it's like covered with dust, and the guy like slamming one case on there, and
yep. So if you're doing a bunch of SKUs at once, it's a faster way of doing that portion of it, and you can actually even integrate it with systems that you have today. Because it's just a sensor, right?
You have it on your receiving sorter, and then you just go ahead and take that data and run it through everything else.
Yeah, or even in your Cubiscan, instead of entering the dimensions on it manually, you just add that on top, and you kind of make it part of your process, and you're good there. Or we've done simple ones in the past where you integrate it with like a desktop Mettler scale and a hand scanner, and all of them are cycled through at once. So we've done a few projects like that in the past, and it's a low cost solution comparative to a time of flight because it's a single piece of hardware.
So how much how accurate can I go with like vision dimensioning? Like can I do like a portray like dimension? Like can I what are the extents of this? Like for sure, like hey, this is too big to go into the next process.
Yep. I would say actually legal for trade is probably the only question mark out there right now for vision based dimensioning.
Yep.
I'm not sure off the top of my head if I know any products that are legal for trade that are vision dimensioners. Those are mostly time of flight sensors.
Yep.
Outside of that, though, like the accuracy, you can get pretty much in line with it. I just don't think they have certifications or whatnot. But that don't quote me on it.
Okay. And like, are there any conditions for vision based like dimensioning? So if something like if it's like rectilinear, like it's probably fairly easy to say like this is the extent of this.
Cuboidal.
Yeah, cuboidal. Okay, that's even cooler. I like that. So like when does a package become a ball? Like what kind of shapes do we need to avoid?
So I think it depends on what you need out of the dimensioner, right? So if I see a vision dimensioner and I'm, dimensioning a basketball by itself, which would never happen because I would just sit there and roll on the conveyor. But if it were, right, you would just be getting a bounding box around that thing. So you're not necessarily gonna see the sphere. There are sensors out there where you can do it and get that level of data. Those are more like displacement imagers or sensors, kind of like we talked about earlier. But typically for an in-motion dimensioner, you're not going to need that level of information. You just want to know what the outside bounding box is. So you either know what box to put it in, or some type of material handling down the line that's restricted by size.
How full it's going to make the Gaylord when I dump it in there?
Yeah.
Provided I can get this basketball off of the sorter.
Yeah. Although I will say to that point of like irregular shapes, some interesting other applications for vision or displacement dimensioners are that looking inside a box to see how full your box is. So you're trying to get a better read on tube fill of your box, or to prep it for void fill. Those are both options that vision dimensioners can do as well. So they can look inside with the flaps up, especially as long as you know what the inner dimensions of the box are, and your system could do a little math, which is just some programming at this point. Then you can get a pretty accurate read of like how full something is, either a tote or a carton.
Yep. Can I add the next unit, or can I? Do I need to put 1 cubic foot of void fill in it, or can I cut the lid down?
Yep.
10 inches.
Or with all those systems out there that like right size their packaging now, you can give them feedback on. I don't know. Yeah, those are options.
Okay. Yeah. Very interesting. Okay. I like that. Okay. So let's say that like I try to use some dimensioning and just to make sure I didn't send it to the next system. But then I do something, I send it to the system and I've damaged some product. Can you figure out what's damaged and what's not damaged?
Excuse me. So yeah, there's a damage detection is kind of an interesting one because that's a challenge, right? There's a big difference between like an overfilled or a divoted box than a puncture wound, right? Like a little, just someone dropped a tool or something and it punctured a box. So if you're just looking for overall, like, is the box bulging or is the box concaved in? That's pretty straightforward to do with a dimensioner of, I think, pretty much any sort. So yeah, vision dimensioning can certainly do that. Usually, like 1 inch or so is the defect size. So as long as the max part of the defect is about that big in either direction, you should be able to see it.
Yeah.
There's a depth. But like looking for something more along the lines of a puncture or a ripped carton or something like that, those are a little harder to do because, again, now you're looking for a model to which to say this is a good package, this is not a good package.
Yeah.
Sensors, embedded sensors probably don't have that today, not to my knowledge anyway. However, there are certainly software companies out there that do use those sensors to provide that feedback to their customers. So it's a little bit specialized, but certainly does exist. It depends on the application, really.
Yeah. So if I had a case of T-shirts and got like they're notorious for, they get kind of crushed, right? And I want to do some vendor compliance. Like that's going to be a tough one to figure out.
What do you mean by crush, though?
Yeah, well, yeah. This is like I've had this conversation. So, how damaged is damaged? And it's a weird thing to ask someone, right? Because like your response as a human is like, well, that's obviously damaged. But to anybody that has to codify anything, like it's not enough to go on.
And my response to the people who say that has typically been, well, you clearly have a certain set of metrics that you're looking at a box and saying, yep, oh, that's damaged. So you need to give me the numbers related to that, and I can tell you yes or no, right?
Yeah.
So yeah, I mean, as long as they have a set of metrics, then it should be doable. I mean, if, like I said, if there's if the max defect is like 1/4 inch, then that might be a little tougher. But if you're looking for box crushing and you know what the box is supposed to be, and then you get the dimensions back of what it is, and you can just set a threshold for it. And
it's like you're deflected this much out to the side, or like a plus or minus 0.05 mil.
Or you need to get outside the error rate of the unit itself.
Okay, interesting. Is that how damage is typically defined when you do damage detection?
Yeah, I would assume so. I don't know if I know all that information of how it works exactly under the hood in terms of the algorithms that support it, but yeah, I would assume that would be pretty accurate to say.
Yeah. What kind of industries or like product like workflows do you see that in?
Damage detection specifically. I'm trying to think of how many have actually deployed over time. Probably only a handful. The most common ask, though, is for large items. So you get like, your knock flat part furniture. They're always looking for trying to determine whether the stuff is damaged. Appliances, well, they want to know if there's like punctures in the outer cartons of their, refrigerators or their washing machines or whatever, right? So those are the most common asks, but I don't know if I've ever actually deployed one for them because the ask on the investment for the teaching of the algorithm is always pretty high. But like I've seen deployments for is the box taped or not, or is the box too full to fit into the ASRS or the mini load, right? I'd say that's probably the most common one is is it over an inch or two outside of our specifications for the mini load.
I see a lot of like the electronics, like condition checking. Like you could like zoom in real tight on a cell phone like that, and but I think the attribute there is like everything's kind of supposed to be the same to a very high degree.
Yeah, and you would definitely use more of like a displacement sensor than like a vision area scan dimensioner for that, because that requires the level of accuracy that's like I mean I don't want to say microns, but probably in that realm.
Yeah. I think it is fairly intense. I don't know how it works.
I mean, when I was back in semiconductor, I used to measure in microns, so I remember the days.
Uh, yep, I'm in. Okay, so what do you think is like kind of next for vision? Like, what should we be looking out for, like, as the next hot thing in the area?
So I would say that you're going to see a lot of the more difficult applications that used to require a lot of heavy computing start to hit either on device or local compute. So I don't know if I don't know if I would expect anything grandiose in the next 6 or 12 months. But what I think you will start to see is the applications that you wanted to do are now becoming more viable, like the ones we've talked about today, especially centering around OCR and classification that were harder to do in the past. I think that, yeah, those are becoming speed-wise viable and now can be start to be considered as part of your toolkit as a material handling designer, right? You can now say, oh, I don't have to just rely on a barcode anymore. I have all these other cool options.
Okay, yeah, it like changed. Like, yeah. So technically speaking, like they're a lot easier to deploy, which means it's going to be a little bit less expensive. And I think there's also some kind of cost pressure on all of the imaging like software or technologies I've seen. Like the prices come down pretty considerably, and there's a lot of circumstances now where like maybe 15 years ago I would have said, nah, you should just barcode scan it or have a guy check it out. Where now I'm like, don't ever have a guy. The guy is more expensive than the technology.
And I think you'll find that like with a lot of these companies coming out with pre-trained models, that everything used to be a science project, right? Everything used to be build it from scratch. Like, here are the rules that you need to teach your vision tool, and then people charging hundreds of thousands of dollars for the R&D essentially to build that engine. Well, now you have these companies, software companies especially, that are basically deploying these things and now just either on an embedded device or using an embedded device, or even sometimes just regular, we'll call them dumb cameras because they don't have any algorithms on them, and just utilizing that device on their compute. But yeah, with them being mostly trained, that these deployments are no longer fully science projects, and they're a little bit picky about what they'll do, right? They're not going to take on something that's going to require them to do a ton of engineering work. But if it's within their wheelhouse, which I think is getting bigger each and every month or year, then it's pretty exciting to see.
Okay. Are there any mobile versions that are like, so I think a lot of the stuff we were talking about, like, it's like a fixed position stuff, like maybe I'm moving the product through it, but as far as like the handhelds or like, transitioning something to like your iPhone is supposed to do everything, right? Like, is that anywhere on the horizon? Do you think that's going to be viable? Do you think that it even makes sense in how some of these warehouses are working, in the next couple of years?
I think a lot of the OCR tools that are already out there run to a certain extent on mobile, and there are certainly software companies I've worked with that can do that, especially along the lines of just like lifting stuff off of a package. But definitely it trends more towards mobile, in my experience, not on like purpose-built platforms, just because the mobile companies have access to a broader set of tools and more compute on their cell phones right. But it comes with its own challenges of maintaining a fleet of devices in your warehouse that are not controlled by you.
Yeah, well, it's always an interesting case. Like I can have a more automated system, in which case I have more fixed resources, and I can make them very powerful, right? Right, you have a scan tunnel, you can do a lot of stuff. It will scan faster than any person in history, or I can have this like sort of like an automated person where I can give this guy a lot of tools.
Yep.
He can go out and pick. And I think the tricky part for me is always trying to figure out what's that economic break point between those two. Like a forklift driver moving a pallet is pretty good, right? Yeah. It's great. And so giving him like an excellent scanner that can figure out a lot of information about that load very quickly, that might be the move, right? It would be very expensive to build pallet automation to do that. But maybe for each picking or unit picking, that might not be the case.
Yeah, I mean, especially if it's got to go on conveyance anyways, then why do it at the point of manual process, right? But yeah, no, to your point, like especially in warehouses that carry 2-3 pallets on those long jacks, yeah, maybe there's an opportunity there to do things on a platform. I can't say that's my most familiar point or a piece of experience, because that's not where I dip my toe into. But yeah, it's certainly. I mean, I've worked with companies that are deploying like sensors and stuff onto fork trucks that are just your standard gas or electric fork trucks that are out there in the world, to try and give those users and operators more data and better pathing, better safety. So I know it's why. Yeah.
Oh, so like, and maybe this is an area I haven't asked about a whole lot, but we do have a lot of sensors on, like, let's say like robotic cells, or my car's got backup detection that says, hey, don't hit the side of your garage. Like, I assume this is an imaging application. Are you seeing like more and more of that, like that safety type of imagers like in the market, or is there like a limitation to using an imager for safety?
I mean, I think you're getting into the whole image vision based versus LiDAR discussion that that's out there in the world, and I'm not sure I have a position on that. But yeah, I actually don't know. Honestly, that's not something I'm super experienced in, but it is an interesting thing to think about, especially with folks tackling installing sensors on these existing fleets, because there was the whole movement for like AGVs or fully automated fork trucks that come with all these nifty bells and whistles, but they're not cheap.
Yeah.
And it's replacing existing fleet. So you've got this transition cost. But now if you can bolt on a sensor onto an existing truck and get like, 80, 90% of what you want out of it. And yeah, it's still driven by a person, but now you have all this feedback for that person to be safer and more efficient. Maybe that's a good interim.
Interesting. Yeah, interesting. Okay. Very cool. Yeah. All right. Well, Scott, thank you very much for taking the time to talk with me. This was very educational for me. I'm always like happy to throw curveballs at my friends and see if they can answer them on a live podcast like that. So that's pretty exciting. And for everybody listening, thank you very much for tuning in. If you've missed any of our past episodes, check us out on Spotify or Apple Music or anywhere that you download podcasts. And we will see you on the next one.
Thanks so much, Joe.